Both.
All right, 6x squared plus 7x plus 2. You guys try this one. Take a minute and try it out. So this is the first problem we see where there's no greatest common factor keying out, at least from the last two problems, right? So this one, we're just going to deal with it as is. No greatest common factor. So I am going to take the leading coefficient of 6 and the constant 2, and we're going to multiply them, right? So 6 times 2 is 12. So I'm looking for two factors of 12 that add up to 7. So I say, well, okay, let's see. 1 and 12 is 13. That doesn't work. 2 and 6, close. It's 8, but still doesn't work. It has to be exact. All right, 3 and 4, we found it. And again, if this was like a negative 7, then both these would have to be negative. Just keep that in mind. So from the 7x, I'm going to split this up into 3x's, positive, and positive 4x's. Now some students get caught up. They're like, what if I want the 4x right here? Do it. I don't care. You're going to get the same answer from this factoring either way. So the first term there, though, let's put in the rest of it. 6x squared plus 3x plus 4 plus 2. So our trinomial now is a 4-term polynomial. And now that we have that, let's go and factor by grouping. So the first pair here, I'm going to factor out, looks like just from the numbers I can factor out a 3. So I'm focusing on the numbers first. 6 divided by 3 is 2. 3 divided by 3 is 1. But then I see that I've got an x squared and an x, which means I can factor out an x from both terms. So the first term still has an x. The second term, we pulled out both the 3 and the x, so we do need this 1 right here. So that's factoring from that first part. Now we'll factor from the second two terms. And it looks like we can factor out just the 2 from both of those numbers, the 4 and the 2. I can't factor out an x here. So I am expecting 2x plus 1. 4 divided by 2 is 2. Then we keep the x. 2 divided by 2 is positive 1. So it does match. So from there, I have factored out, from these two terms, I factor out a 2x plus 1. And then I just write in what's left, right? So the first term had a 3x left over, and the second term had a plus 2 left over. Now again, just before you finish here, just make sure there's nothing you can factor, some kind of greatest common factor with each binomial separately. I don't see any. So it looks like this one's done. And again, if you wanted to write this as 3x plus 2 times 2x plus 1, it's the same exact thing. All right, so this is a good point. If you reverse the 4x and the 3x right here, right? So I'm skipping the first part. You're going to get the same answer, and here's how. So the first two terms, now I can factor out here a 2 and an x. So I'm skipping some of the math here, but that leaves me with a 3x. And then from the 4x, we factored out a 2 and an x, so we're just left with plus 2. And then we got this other one right here. Now, there should be something that's factored out, right?
1.
So, yeah, but there's nothing. Yeah, there's nothing to factor out right here. We do need to see something factored out, so that's, yeah, we'll just show it as a plus 1 factored out. And now it does match, a 3x plus 2. So, because some students are like, well, it already matches right here. That's true, just factor out a 1. And now I factor out a 3x plus 2, and I'm left with the 2x plus 1. So thanks. That was a good example to show that, because if you get to the point where you can't factor out anything, factor out a 1, and you'll see that, again, it's the same exact thing, just now the order's changed, just the way that I'm writing it.